Namaskar my dear friends. Let us talk about battery charger ICs. So one of the battery charger that I have taken from Texas Instrument is BQ25171-Q1. So it is automotive grade battery charger IC. So these battery charger ICs are used in various locations, various places for batteries like one or two cells of lithium ion batteries or lithium phosphate batteries, or like nickel metal hydride batteries, NiMH batteries. Okay. So we will see this training in two sessions. First we will understand what is the battery charger ICs, their details and design process, and then we will also see the design implementation. So I have three applications using this particular battery charger IC, each one for lithium ion, lithium phosphate and NiMH batteries. So I'll give you a very simplified schematic, like operations details, like what do we do basically. Very simple, like to design this particular ICs is just we have to concentrate on some of the particular items. Basically, what is the voltage setting? So based on one resistor values, you will be able to set what is the voltage output that you want at the battery charger output, right? So this is your V output. So using this particular resistor, you will be able to set the output voltage. Similar to that, what is the charging current? So that is set by I set values. So this is the resistor which will help you to set the output current of the battery charger IC, right? So what is the current that you want to charge with? That will be set by this I set resistor. And what is the charge out timer? Let's say you want to charge for 5 hours or 2 hours or 3 hours. So based on the battery chemistry and the number of cells, you will decide a nominal amount of time. Okay. And whether the battery is completely charged or not, that doesn't matter. You want to cut off the charging. Okay. So charging process cannot keep on going indefinitely. Okay. So that's how you will be setting particular charging timer as well. So with these three resistors, these are very important resistors to like set some parameters for your battery charger design. Similar to that, you have some status LEDs. So status LED 1 and status LED 2 are there. So they will be used for indicating whether battery is completely charged or not. Okay, based on their status, like whether it is blinking or whether it is continuously glowing, something like that. And similar to that, other status will be used for what is the fault type. If there is a fault in charging status, whether it is a recoverable fault, like it can be recovered easily, or whether it is non-recoverable fault, so it means the battery charging will stop immediately and it will not resume back. Okay, so this is the basic idea of designing complete battery charger IC for your any application that is there at your hand. Okay. So with this introduction, we will proceed for design and detail of this particular battery charger IC, and this can be used up to 800 milliampere current output that you want it. Okay, and the input voltage, as you can see, the input voltage can be taken from 3 volt to 18 volt. So this is most suitable for your like 5 volt application or 12 volt application, even 9 volt application. Okay, so these three voltage applications, this is much more useful, and here you will be able to utilize it with your lithium ion, lithium phosphate and NiMH chemistry batteries, as I already mentioned you. So let's deep dive into the charger IC detail. So I'll just open this particular document that we have created during our like design phase. So we have the linear battery charger IC, which is BQ25171-Q1. I'll give you the complete part number of this particular IC. And as you can see, we have some of the understanding, as I already mentioned the description, that this is automotive grade standalone battery charger IC, and this is having VSON package with 10 pin. Okay, so this is just 3 mm cross 3 mm package, so this is very small. And as you can see, we have some of the applications for this particular IC, which is a telematic control unit or emergency call, okay, or fleet management and asset tracking or remote keyless entry. So there are a lot of remotes that are coming. So for that battery charger ICs, this particular battery charger IC will be much more useful. And as you can see, battery chemistry, it is applicable for lithium phosphate, lithium ion and NiMH. Okay, so this is most like useful IC that I have considered in my past previous experiences. Okay, that this particular IC is applicable for almost all the kinds of battery chemistries. So this is very versatile. Some of the features that if you want, you can see the V set to set the battery regulation voltage from 3.5 volt to 8 volt battery. Okay, so this is the like voltage setting pin that will be used to set the output voltage for your different battery chemistries. Similar to that, I set will be used to set the battery charger current, which will be from 10 milliamperes to 800 milliamperes. Similar to that, we have charging timer, which will be used to set the charge timer duration. Okay, so this is how we will be using this particular three pins to set those particular values. Okay, now we have some of the features that we can see. We have pre-charge feature, which is 20% of iset. Let's say iset is set to 100 milliampere, then pre-charge current will be 20% of this. It means it will be 20 milliampere. So 20 milliampere will be the current which will be in pre-charge mode, right? Similar to that, termination current will be 10%. It means that will be 10 milliampere. So with these particular values, I am calculating and telling you the values. Okay, so similar to that, you can have 20% of like 200 milliampere or 500 milliampere based on your charge current that you have decided, right? It has the NTC thermistor input also, which will monitor the battery temperature. So negative temperature coefficient thermistor will be used to measure the battery temperature. If you want to utilize this feature, you can use it. Otherwise, you can leave it open. Okay. We have CE pin for charging function control, whether charging is being like done or not or something like that. And we have two open drain output for a status fault that we have already seen, like a status 1 and a status 2. We have some integrated fault protection, like if there is a voltage more than 18 volt, then there is over voltage protection. We have VSET based on output voltage protection. So whatever the VSET that you have set, the output voltage protection will protect. I mean, it will not let the VSET reach to higher voltage whatever you have set. Okay, we have maximum charging current, which will be like protected up to 1000 milliamperes. So 800 is the maximum current rating that it will give you, but if by mistake it reaches to 1000 milliamperes, then it will cut off. Okay, and we have 125 degree centigrade working temperature. Okay, so the temperature range of IC is up to 125 degree very easily, and it can work up to 150 degree centigrade, which will be a thermal shutdown like a stage. Okay, and we have output short circuit protection, and we have open circuit and short circuit protection for VSET, that is voltage setting, current setting, that is charging current setting, and charging timer setting. Okay, good. So with this, we'll just proceed to pin description. So as you can see, this is the particular IC that we were talking about. So we have 10 pins, which is having input pin, iset pin, that is current setting pin. We have CE pin, TS pin, that is like temperature setting pin or something like that. We have ground pin, we have charging timer, we have status 1, status 2, and voltage setting, and this is your battery charger voltage output. Okay, and we have thermal pad also for heat dissipation properly. So if you want to have a quick look on like what is the pin functionality, so input voltage, as I already mentioned you. Okay, so DC supply input will be there, and you have to bypass this with a capacitor. Okay, so that and all I will like give you all these information during the design phase. We have the I setting. So I setting you can take up to like 10 milliampere, which will be used for 30 kilo ohm, to 800 milliampere, which will be used by 375 ohm. So from 375 ohm to 30 kilo ohm resistor variation, you will be able to achieve a I set of 10 milliamperes to 800 milliampere. Okay, and this is the formula that will be used. I will tell you this as well later on. We have charge enable battery. So if you want to have a charge enable something like that, then you can utilize this particular pin. Otherwise you can keep it in default mode. So if it is floating, then it will be always charge enabled, and if you want it, so it is active low. So if you pull it high, okay, then battery charging will be stopped, and if you pull it low, then it will be like enabled. Similar to that, TS pin, which is temperature qualification. So temperature is within the range, then like battery charging will operate, otherwise it will terminate. So similar to that, other pin functionality is also there, which we have already considered. Okay, now let us talk about simplified schematic. So I already mentioned in the introduction phase that we have charge timer capacity, like resistor setting, then voltage setting resistor, then current setting resistor. So these three are most important for your any battery charger IC design. So this particular concept you can extrapolate for any other ICs as well, like you want to design battery charger for your using different ICs or using different battery chemistries. So these three are most important parameters that has to be taken care in any of the battery charger design. Okay. Similar to that, we have a status pin. There may be a possibility of some of the ICs are having only one status pin, or maybe having some two or three or four also. Okay, based on the different conditions. We have CE pin, which is charge enable pin. So generally some of the ICs will not be having charge enable, because that will be by default. Whenever you give the power input, there will be power output, and this is a functionality like using microcontroller or something. You can disable the charge with even the input is connected or not connected, that doesn't matter. Okay, so this is a simplified schematic that we have already talked about. Okay. Now coming back to electrical characteristics, so this is very important. Your nominal input voltage must be between 3 volt to 18 volt. Okay, so this is the recommended voltage rating. Okay, so generally I will be using 5 volt input or 9 volt input, or like 12 volt input. Even 6 volt are being used somewhere, but 5 volt is like very close to that. So generally 5 volt is a standard voltage. That's the reason we utilize that. Okay. And we have output voltage maximum 10.5 volt you can take, but it was recommended that up to 8.5 volt or something is considered. Okay, and we have maximum current rating also 800 milliampere. So this is the particular recommended operating conditions that will be utilized, okay, to make sure that whatever the parameters or whatever the voltage output or current output that you want, it should be within this particular range. You can see input capacitor must be minimum 1 microfarad, output capacitor must be minimum 1 microfarad. So those also we will take care of. We have charge timer resistor, so that will be used from 3.6 kilo ohm to 100 kilo ohm, and 3.6 kilo ohm to 100 kilo ohm for your voltage setting resistors as well. And we have iset resistor, which will be 375 ohm to 30 kilo ohms. Okay, as you can see, the voltage setting and charge timer like setting that remains between plus minus 1%. So this is very accurate. Like whatever the voltage output that you have set using the resistor, the output setting will be plus minus 1%. Okay, so coming back to the thermistor. So thermistor resistor is nominal 10 kilo ohm. So based on that, you will be able to utilize your thermal setting. So typical application we'll see at last. Let us see the detailed design overview. So detailed design overview is nothing but like this is a design documents. That's the reason I have like captured almost all the points. But we'll see one by one what is the design like detailed design procedure. First of all, we have to understand based on different battery chemistries. Like let us talk about lithium battery charging. Okay. So what happens is this is a lithium battery charging profile. So what happens is you have some of the like characteristic that you have to take care of. So let's say I pre-charge. So I pre-charge is this is the charging current that is there, which is in pre-charge mode, and as soon as it reaches into like I mean charging condition, then the current, as you can see, has increased. Okay, so it has increased. And then charge regulation phase. So this is the I charging that you had set during your like I set settings, and this is the charge current that will be taken care, nominal values that you have set down. And after that, what you have to do is you have to take care of like post charge regulation. So post charge will be slowly coming down, and then it will be terminating like this, which will be almost 0 ampere. So this is how pre-charge mode timing, and then this is safety timing which will be considered. So this is the timer that you have set using like battery chemistry timer setting, and then this is a done phase. Okay, so this is the complete battery charge profile, that is reasonable for lithium battery charging. Okay, so this is what we have to take care of. Coming back to the other profile, let us talk about a functional block diagram. So any of the data sheet, if you see, you will be given the IC block diagram. So as you can see very easily, this is your input voltage, which is like coming with one capacitor. This is your output voltage, which will be going to your battery charger. Okay, so this is how battery will be charged here. Okay, now coming back to charge enable pin. So charge enable pin, if you want, you can keep it by default mode, which is active low, and similar to that we have I setting, voltage setting, and charging timer setting. Okay, Then coming back to a status pin, so you can see we have a open drain output pin kind of thing, so you have to pull it up, then only it will be whenever a status pin goes low, then it will start blinking. Okay, similar to that, a status pin goes low, then it will start blinking. So based on the condition that will be mentioned in the datasheet, I'll explain you, like based on what condition, what is the status of these two pins. Okay, similar to that, you have a thermistor pin. So thermistor pin, if you want, you can keep it open, otherwise you can ground it with a 10 kilo ohm resistor, which will be utilized by default. Okay, so this is how a complete block diagram that is like given from the data sheet. So this is the input through the MOSFET settings and MOSFET switching. This is the output that is being done. Okay, and all these pin detect and reference DAC, like digital to analog converters, and iCharge, V battery reference, or timer safety, or timer like regulation. So all these things are taken care by all these settings. Okay, now let us talk about iSet pin. So iSet pin, what you have to do is I charging that you want to set, that will be utilized using K iSet by R iSet. So let us say I charging, I want it 300 milliampere. So if you want to have, then what will happen, my R iSet, it will be utilized as K iSet divided by I charge, which is 300 milliampere. So this is how you will be able to find out the value of iSet resistor. Understood? So there are several like data that is already given, so which we can utilize and understand. Okay, similar to that, we have a charge timer like recommendation. So charge timer recommendation, as you can see, we have lithium plus batteries or NiMH batteries. Okay, and based on that, if you want 5 hours of timing, then you have to give 100 kilo ohm. If you want 10 hours of timing, then you have to give 82 kilo ohm. Okay, so this is how charge timer will be utilized. So if you are using lithium ion battery, okay, and in that case, if you are using 82 kilo ohm, then it will be giving you 10 hours of safety timer. Got it? If you utilize 62 kilo ohm, then timer will be disabled. It means it will be charging indefinitely. Similar to that, if you are using NiMH battery, then NiMH battery, if you try to use with 36 kilo ohm, then it will be giving you 4 hours of timing. Similar to that, other values will be used for other timings that you want it. Okay, coming back to VSET pin detection. So VSET pin detection, what it says is, let us say, let me give you an example. There is no calculation here, but it is very easy to understand. Let us say you want to use one cell lithium phosphate battery. Okay, so for that you need 3.5 volt output voltage. So for that you have to use 100 kilo ohm. If you utilize 82 kilo ohm, then output voltage for the same configuration, it will be 3.6 volt or 3.7 volt for 62 kilo ohms. Okay, so how much voltage do you want at the output? Based on these three resistors, okay, you will be able to set it. Similar to that, lithium ion batteries, for 3.8 volt you have to utilize 47 kilo ohm. Okay, if you want to use two cells or something like that, so then it is like accordingly. Now if you have NiMH cell configuration, let us say one cell NiMH configuration, then what will happen, you have to utilize 62 kilo ohm. Similar to that, if you have to use 6 cell, so 6 cell configuration, if you have to use, 4.7 kilo ohm VSET resistor. Okay, so that will be giving you 8.2 volt at the output. Got it? Now as you can see, we have charging power up. So after VSET, iSet and charge timer, pin resistors values has been validated, then only device proceeds into the like charge enable mode. So all these three values, if they are set properly and they are validated by the IC, then charger will be enabled. Now charging profile, as already mentioned you, like we had the charging profile of lithium ion battery charger, like there was pre-charging mode. So there is, before that pre-charging mode, there is a trickle charge also. So if you go very detailed, okay, then we have trickle charging, we have pre-charging, we have constant current, which is set by iSet current. Okay, that is I charging current, I charge, and we have constant voltage output, that if you want it. Okay, so you can see in the beginning, battery charger voltage, like battery voltage is very low here. Okay, and this is slowly increasing, so see, it is because of trickle charge was happening in the beginning. Okay, and then there is pre-charge mode, and then it has reached to the I charge, like whatever the set current that was there. So you can see battery voltage is slowly increasing, like in a linear fashion. And later, since it has reached to the like V set voltage level, like whatever the voltage setting output has been like reached, then it will try to maintain this. So in that case, you don't need a current, like we don't need charging current, so that time it starts slowly decreasing. Okay, and you can see it reaches to termination current. And if there is a sudden dip in the battery voltage, then suddenly it will increase, like there is no need again to go for pre-charge mode or something, because battery voltage is already little bit higher side. Okay, so recharging, like you see battery recharging, what will happen? Immediately it will reach to the I charge phase, and as soon as it makes it reach to the battery voltage, it will again start coming down. So you can see this phase again does not repeat from here. Okay, this complete thing. Okay, like from here directly it reaches to the I charging. Okay, so this is the complete charging profile for your lithium based batteries. Similar to that, NiMH batteries, so for each one of them there are different battery charging profile. So as you can see, NiMH, there is no pre-charge or something like that. You have directly going to iset, and in iset mode you have to have the constant current there. And as soon as it reaches to battery over voltage protection setting, okay, then the battery charging current goes down. So this profile is just because I'll tell you the reason why battery charging profile for different battery chemistry are different. Lithium batteries are very prone to like a blast or something like that. That's the reason we don't want to charge with immediately iset values. We want to charge slowly, pre-charge, then go into charging phase, then discharge. Reduce the current charging. But that is not the case in the NiMH batteries. Okay, you can directly give the iset values and then directly reduce it to 0. Okay, and you can see slowly the battery voltage is increasing in a linear fashion, and it reaches to the battery voltage whichever set by V set. Okay, coming back to the another profile, same lithium sorry NiMH battery profile. So what happens is, let's say after this battery charging there is a dip or there is a discharge phase. So in that case, immediately after that time duration, it will immediately go to I charging phase and come back to the zero current at out I set. Okay, once it reaches to the battery charged condition. Okay, so you can see the complete timing is from constant current, like a CC mode. Okay, got it. Now coming back to the status LED, as I was talking to status, there are two status pin, one is a status 1, one is a status 2. So status 1 pin state and a status 2 pin state is there. So as you can see, a status pin was something like this. Okay, uh, it was like this. So this is my status 1 and this is my status 2, similar to that. Okay, and this is the LED. So let's say this is my V3 is connected. Okay, 3.3 voltage connected, this is R. So whenever a status pin goes low, then only it will glow, that you have to understand. So as I told you, charge completed. So charge completed means if this goes high, it means it will not glow, so it will cut down. So if it is not glowing, it means you have to understand that charging has been completed. Got it? Similar to that, a status pin will also go low, so that LED will also not glow. Now normal charge in progress. So if normal charge in progress, then what will happen? This will not glow, like this status LED 1 will not glow because it is high. Okay, but status 2 LED will glow because charging is in progress. So if charging is in progress, say this is my status 2 LED. Okay, 3V3. So this will keep on glowing continuously. It means you have to understand that charging is in progress. If recoverable fault, then first one will go low, that is it will glow, and second one will go high, that is it will switch off. So it means you have to understand, see, when it was glowing, low means glow. Okay, glow, then you will see that it was charging, but once it goes off, okay, so high means off, then what will happen? You have to understand that it is recoverable fault. And if both are glowing, both are low, then what will happen? If both are glowing, then non-recoverable fault. Okay, so battery charger will enter into the stop mode. Okay, Good. So this is how it was there. Then we have already understood fault mode or something like that. So let us talk about what are the different fault modes. So different fault modes are we have like over voltage protection, battery over voltage protection. We have hot, or we have cold, like thermal shutdown hot and thermal shutdown cold. So let us say you want to charge your battery between 30 degrees centigrade to 44 degrees centigrade. So before this it will be cold shutdown, and after that it will be hot shutdown. So even if battery charger like increases temperature increases more than 44 degrees centigrade, then also it will be telling you as a fault mode, and if it goes below 30 degrees centigrade, then also it will tell that it is like I mean fault mode. So generally we try to go ahead with battery charging IC from 0 degree to 40 degree or 45 degrees centigrade general condition, or maybe 10 degrees sometimes. Okay. Non-recoverable faults are whatever the non-recoverable faults, those were recoverable, right? Non-recoverables is battery over current protection. So as we were talking about like non-recoverable faults, so non-recoverable faults means like once it sees something like that, battery over current protection, okay, then it will not recover, like it will go into shutdown mode. Similar to that, if ISET pin is shorted, okay, like ISET pin has reached that it is short circuit. So short circuit means it will try to give you like a lot of current, okay. Or otherwise if V pin is open or short, or if charger timer pin is open or short. So these four condition it will tell you that it is non-recoverable, means it has reached into non-recoverable phase. Coming back to the application and design implementation, so as you can see from the data sheet itself, okay, so we have design procedure, so we have design requirements, we have what is the program, the fast charge current, so as I already mentioned you, then TS function, that is thermal shutdown function. Then we have output voltage setting, and we have battery chemistry and safety timers, and we have default charging enable by CE pin, that is host pin, okay. So these are the design requirements, these are the design procedures, okay. Coming back to requirements, that if you want, so requirements is nothing but like you have to tell like what are the things that you want at the requirement side, like input power supply up to this much, or what is the battery chemistry, or how many cells, what is the fast charge current setting that you want to give, what is the charging voltage level that will be there. So as you can see, lithium ion battery charger is generally 3.7 volt, so 3.7 into 2, that is 7.4 volt, okay, but generally it reaches to 4.2 volt also. So I have kept the battery regulation voltage up to 8.2 volt, it means 4.2 into 2, that is 8.4 volt it is going, but I want to keep it up to 8.2 volt. Got it? So this is how it is calculated. So I am giving you the calculation as well. Safety timer, you set down like set it like how much time that you want it to charge, so 5 hours it is. And we have termination charge current, so how much you want it to 10%. Generally it was told also in the beginning. We have pre-charge current, which is 20% of high charging, which is going to be 20 milliampere, because it was 100 milliampere high charge current. We have thermal shutdown, which is temperature sense pin, okay. So temperature sense pin is going to be a 10 kilo ohm NTC, which is 10380. This is very standard NTC resistor, and charging is allowed from 0 degree to 45 degree centigrade, which I already told you. Similar to that, we have CE control pin, so we will like pull it high to disable the charger, and pull it low to enable the charger. So this will be by default, we will not be using any microcontroller to enable disable this particular understanding. So alright guys, this is the complete design details, design process. In the next session what we'll do is we'll try to understand the complete this particular charger IC using 3 applications. So design implementation using 3 applications, we will see what we have done in our particular industrial like designs, okay. So with this we'll try to explain all these 3 like different applications. One of the application is using lithium ion, then another one is lithium phosphate, and next one is NiMH battery. So if you do have any questions regarding the linear battery charger ICs, and how to select the particular IC, and what is the output setting current, or what are the different phases of design for battery charger IC, you can put down your questions in the comment box, and we shall be able to answer you out. Thank you so much.